If it happened to you in the past that you needed to understand what is the performance of your application on an actual server and then you SSH'd into the server, then as a software developer or software engineer who is not a system administrator, you do not run the commands to understand the performance of the server on a daily basis. I thought this could be a great checkpoint for software engineers to see what are the top most required commands to run in order to see the performance of a specific server once you SSH to it. Again, as we are not system administrators, we do not run this command on a daily basis, and there are actually only a few commands that we need to run in order to get a good understanding of what's happening with our Linux server. Once you have SSH'd into your server as a software developer, you want to know these main points about your server. You want to know how loaded is the server. Are there special processes which consume much of the resources? Are there any specific errors that the server is reporting? How much time is this server up? Was it restarted recently? Is it a new instance? What's the status of the memory of this server? How much is used on the user space, meaning the actual applications, and how much is used by the system, means the kernel of the Linux, because you can split the CPU usage in between your actual applications and in between how much work does the OS need to perform. You also want to know the status of the CPU. You want to know how many tasks are waiting to be executed on the CPU, meaning there is a waiting line. Is this waiting line on the CPU growing or shrinking? How is our status now with relation to the past? Are things going to be better? Can you see that the CPU is getting better and better, or are things going worse? Also, so we want to know in general the status of the server, the CPU status, the memory status, whether we have too many paging, the virtual memory status, the disk I/O, how much are we utilizing the disk, and the network. Are we maybe utilizing the network too much so that the network card does not have any additional capacity? And how can we get a global overview in addition to specific metrics? The commands that you as a software developer can run on any Linux box in order to get a pretty good view of the previous metrics are the uptime, the MESG in order to see the error messages that were run recently, the VMstat, virtual memory start, the MPstat in order to see the processes status, PID stat, IO stat to get the disk status, free command in order to get the status of the memory, and the SAR command in order to get the status of the network. The top command is a command that would show you a global summary of everything that is going on, but it's less convenient to view like a historical view and trends. It's more like giving you a refreshing snapshot. So let's start with the uptime command. The uptime command would give you two main data points in order for you to understand the status of the servers. The first data point that the uptime command would show you, as its name is uptime, is how much time is the server up. And this would already give you a hint into what's going on, because if you see that the server is up only for 10 minutes, then you know, oh, maybe this server was replaced by another server because there was some kind of an error. However, if you see that this server is already up for weeks or months, then you know that nothing drastical has probably changed in manner of replacement of the server, or whether the server is new or whether it was restarted. So this is the first data point that we already see with the update command, how much time is the server is up and whether it's restarting. The next data point that we get by the uptime command is the load averages. The load averages is simply the number of tasks that are waiting to be executed on the CPU. So it's giving you an exponential moving average. You get three numbers like 20, 15, and 12. So when you look at these three numbers, then you know that each number is saying the exact thing. So each number is saying how many tasks are waiting, which is the load average, to be running. They are practically waiting to run. So the higher the number, this means that you have more tasks waiting to run. How many tasks do you want to wait to run on the server? This depends on the number of cores and number of CPU that you have. The general rule of thumb is that if this number is equal and not growing to the number of cores or number of CPU, then you're okay. If the number is growing, and how do you know if this number is growing or not? You know this because the three numbers that you see are 1 minute moving average, 5 minute moving average, and 15 minute moving average. So if you see a higher number on the 15 minute moving average and a lower number on the 1 minute moving average, then you know that the situation is getting better, because it's referring to the recent 1 minute and giving it more weight. The next command that you probably want to run is to know whether there were specific error messages, something critical happened on the server, and you use the command dmesg, which prints the important messages, the last system messages that happen on the server. And when you run it, you look at these messages and you look for something critical, like there is no memory or some kind of critical error. So if you see there is some kind of an error, then congratulations, you might have found the error that happened and that is causing you for problems in the server. And now to get better details on the status of our server, after we have run the dmesg and the uptime command, we want to know what's happening with our memory and whether we have too many paging on our system. So we run vmstat 1, which means run the vmstat every 1 second and report to us back. You would see various metrics on the memory. A few of the important of them is the free column, which is the free memory in kilobytes, and the SI and the SO, which is swap ins and swap out. You want to see in the SI and the SO, you want to see zeros, which means no paging and your system is healthy. If you see the paging, this might mean you're running low of the memory. Although it is called vmstat, it's not necessarily about memory. It's also about the CPU and the breakdown of the CPU time. So the columns named US, SY, which is a user, and the system, ID, idle, wait, WA, and SD, which is stall time. So basically, when you look at these columns, you would see a break of the CPU time into how much time is occupied by the user memory, the user CPU, and how much time is occupied by the system CPU, which is the kernel. If the kernel is occupying the system time more than 20% of the CPU, then this is interesting, because this is not really a job that you are doing. Your job is your application which is running. So more than 20% of the time which is being spent on the system time is something to take notice and look upon. If you notice, we have started with some global commands like uptime. Check the overall server, how much time is it up, and then dmesg, which is check the overall error messages, and then the vmstat, which is check the overall memory and the CPU usage. And now we're going to get closer to the processes in order to pinpoint which process is maybe consuming most of the CPU. And we do this again with the PID stat 1, which the one denotes again that what we want to achieve is to print the command and to run it every 1 second, and we would get in the result a list of processes along with the process ID and the user CPU time and the system CPU type. So in this way, you can know exactly how much CPU a specific process is consuming, and If you have a multi-core or multi-CPU, then you would see values greater than 100%, and this is common to multiple commands. If you see a result more than 100%, this in most cases means that you have a multi-core and each core can get up to 100%. So with the PID stat1, you print every 1 second the processes and how much CPU they consume, either a system or user CPU. Once you know all the CPU and the memory consumption and how much time the server is up and the general error messages, you want to move on further. As we said, we want to know also the disk status and the network status. To get the disk status, we run the command, you can guess it. If it was for processes PID stat, then for disk it would be IO stat. So we run IO stat 1, which means run this command again every second, and we look at the columns RKB per second and WKB per second, which is the number of kilobytes per second that are being written and being read. Also, the percentage util is the device utilization, which is in percentages. So you can see how much is your device busy, okay? How much it's taking basically for each second. How much of the second was this device working? So if it was working for the whole second, it's 100% for this second. And if you see values larger than 100%, then this means that this device is saturated or most probably saturated. So IOStat you use in order to get the metrics for the disk usage and how many bytes are written, how many bytes are read. And you look at the await command, which is the average time that it's taking for the I/O. This is the time that an application suffers. The larger the time, then the greater the chance that you have a saturation. You can use also the global free command in order to get metrics about overall your memory. And now you want to get into the network because you have already looked at the disk, the processes, the general error messages. And in order to look into the network, the command is SAR, S-A-R. So again, you type SAR with a few arguments. And with these arguments, especially the one, you tell it run every 1 second and tell me how much network is being utilized. So if you look again, it's not surprising at the columns RXKB and TXKB. This would show you how many bytes per second are being utilized. So if your Ethernet card is of 1 gigabit per second, then you look at these metrics and you say, okay, did I reach only maybe 22 megabytes per second? So this means I'm about 20% of my max utilization of the network, so everything's appear to be fine. But if you get closer with the SAR command to the amount of time, which is to the amount of data that you can send and receive from your Ethernet card, this means that you are getting into the limitation. And the last command is a global overview of your server, because you can run all the separate commands, but you can check also a global overview, but you do not see it in a rolling way, in a historical rolling way, the top command. The top command, you see like almost all the metrics that we saw below. You see the load average, which is the number of tasks that are waiting to be executed on the CPU, and you expect it to be in general equal to the number of CPUs that you have. You would see the memory, the processes, the virtual memory, and in general how much of your CPU is consumed and how much of your memory is consumed. So you can use it as a general screen to see your general server health. To sum up, as software developers slash software engineers slash programmers, we sometimes need to access a Linux server and check the performance of the server and of our processes. So we are not a Linux system administrator, so we do not do this all day. But the point to take from this episode is that there are basically a few commands that each of us should at least and know that they exist and get additional details from the internet, from searching, And these basic commands are what we want to see in this server. We want to see how much memory we have. We want to see how utilized are the CPU, how utilized are the disks, how utilized in the network, and we can get all these metrics in a very simple way and check the distribution of the CPU consumption in between the system, which is the kernel CPU, how much time and how much CPU is the kernel, the OS is consuming, which is not our application, and the user CPU time, which is time which is in CPU process power which is consumed by our application. So if your machine consumes like 100 watts, then you want to allow like 20 watts to the operation system, and I want the most of the watts, like 80 watts, I want to my processes. And we can get all these metrics with these few basic commands like iostat, padstat, sar, dmesg, top, and uptime, which is the first command. Simply know how much time was this server up and its load averages in the recent 1, 5, and 15 minutes. So I hope we all benefited it, including myself, to recap and restructure us and how can we quickly as software developers find what are the basic metrics that we want to understand about the performance of our servers and our processes in a Linux box, in a Linux machine.